Hello, ladies and gentlemen. Welcome back to Chapter 2, where we are talking about the different solutions and things about solutions. Today we are in Solutions Part 5, and we are today going to be talking about how to measure the concentration. Now, there are numerous ways to measure the concentration of solutions. However, they will all fit this general pattern, but you need to make sure that you pay attention to the specific patterns as we go through the different things. Okay, first off, we are going to talk about how to find the concentration of percent by mass. And if you can see, it follows the same basic pattern. You have the mass of the solute, remember that's what gets dissolved, divided by the mass of the entire solution, not the solute or the solvent, but the solution, so the whole thing. And then because you're dealing with percents, you multiply it by 100. So a sample problem. Ocean water has about 5.25 grams of dissolved salts in every 150 grams of solution. And it asks, what is the concentration of dissolved salts? Okay, so you're going to do concentration percent by mass. You have 525 grams of the dissolved salts, which are the solute. They're the dissolved things. And the mass of the solution is 150 grams. That's the ocean water. Okay? So you have 5.25 grams, you have 150 grams, and you multiply that by 100 to get your percent. So you plug your numbers into your calculator, and what you will find is that the percent by mass of the solutes is 3.5%. So that means out of the total mass, 3.5% of it is the dissolved salts. Okay, so you can do that by mass, and what you'll always see is that it will be in grams, or at least it has to have the same mass units. So either grams in grams, kilograms, kilograms. It doesn't really matter, but they have to be the same. Okay, second way to measure concentration is percent by volume. Remember, volume is how much space it takes up. Okay, it follows pretty much again the same pattern. You have the volume of the solute divided by the volume of the solution times 100. So again, it's solute over the total solution, not the solvent, but the total solution. Okay, sample problem of this would be vinegar has about 7.5 milliliters of dissolved acetic acid. That's what kind of gives that vinegar a sting in every 150 milliliters of vinegar. So, what is the concentration of acetic acid in the vinegar? So, concentration percent by volume. You have the volume of the solute, which is 7.5 milliliters of the acetic acid, and you have 150 milliliters of vinegar. Again, it does not matter which units you have as long as they are the same units. And in this case, they're milliliters. You multiply that by 100. You plug the numbers in your calculator, and what you'll find out is that vinegar is about 5% acetic acid. That's kind of why your nose burns if you try to smell vinegar, is because of that acetic acid. Now, something that is quite different in the way that it looks, and it relates back to the last chapter of stoichiometry with our friend the moles, is molarity, which is abbreviated by a capital M, and please make sure that it is a capital M, because something else is lowercase m. In fact, there's a few things that are lowercase m. In any case, molarity equals the moles of solute, remember our friend, in 1 liter of solution. Okay, moles, remember, leads back to stoichiometry. No, you can't quite forget it yet. However, it won't be as complicated as before. In 1 liter, and it is always 1 liter. Okay, so the question would be, what is the molarity of a solution that contains 3.4 moles of solute in 255 or 45 milliliters of solution? Okay, so molarity, you have your 3.4 moles of solute. It doesn't really matter what solute. You have 3.4 moles of it. And you have 245 milliliters. Now, remember, if you look at the formula, it says 1 liter. 245 milliliters is not 1 liter. So you have to convert your milliliters into liters, and you have to use that mole ratio, or not a mole ratio, have to use a conversion factor. Sorry, talking about going from milliliters to liters, etc. Okay, so since you have milliliters on the bottom, you're going to need milliliters on the top. And for every 1,000 milliliters, you have 1 liter. Okay, so milliliters, milliliters will cancel out. Okay, this will go and convert to moles per liter because milliliters cancels. So all you have to do is 3.4 times 1,000 divided by 245. This right here is your conversion factor to a milliliter to a liter. And what you should find is that you have 13.9, with a molarity of 13.9 moles of solute. Okay, 13.9 is the molarity. Okay, so that is going from moles and liters. It's talking about kind of chemical substance versus the volume in that version. Okay, if you're but the main thing here is that it has to be in liters. Okay, so you will want to remember this conversion factor if you're going from milliliters to liters. If you need to look up the other conversion factors, that is fine. Okay, the last method of talking about how to measure the concentration, do not confuse the names. You have molarity, that is moles per liter, and you have molality, which is moles per kilogram. Okay, molality and molarity, don't blame me, I did not name them. Okay, so a sample problem would be, what is the molality of a solution that contains 30 grams of sodium chloride, table salt, in 400 grams of water? Okay, so salt water is what we have. Okay, you will notice we have our ingredients up here. We have sodium and chlorine because we're going to have to know about dealing with moles in this version. Okay, so molality equals moles of solute. You will notice we don't have moles of solute. We have grams of solute. So we put down our 30 grams of solute. And it goes over kilograms. We don't have kilograms. We again have grams. Now, first off, we are going to change the grams into kilograms. So we're going to need our conversion factor here. Okay, so we're going from grams to kilograms. If you have grams of water on the bottom, you have to have grams of water on the top. And for every 1,000 grams of water, you have 1 kilogram of water. Okay, so this is how we're getting our grams of water to kilograms. Remember, grams will cancel out. Now, we have to change this 30 grams of salt, sodium chloride, into moles. So this is where we're going to need our mole ratio from last chapter. Remember, for every 1 mole of something, all you do is you come and you look at the periodic chart and you add up the atomic masses. So you would add 22.990 and 35.453, and you get the remarkable number of 58.443 grams of sodium chloride in 1 mole. Okay, so grams of water cancels out, grams of water cancels out. You have kilograms of water. Then on the bottom, you have grams on top of sodium chloride, grams on the bottom of sodium chloride. You have it still in moles. So all that is left is moles and kilograms. You plug all the numbers into your calculator and you will get 1.28 as the molality of the saltwater solution. Okay, feel free to go through the video as many times as you need in order to solve the problems which you are given. If you have any questions, feel free to contact me, and I will talk to you later.